Hi students, I just wanted to get back in touch with you regarding problem 711C. A question came up on an email and I wanted to respond to that, and instead of making up my own problem, I thought what I would do is guide you through this problem, and hopefully that will really help in case you come across any other problems that are very similar to this. Okay, so here we are in problem 11C, and as I'm looking at the textbook, it says the following. Suppose that we randomly select a sample of 64 measurements. Okay, so I'm reading that, and that's these 64 that it's referring to here. This is the note that I've taken. The sample size is 64. Okay, from a population having a mean equal to 20. So here is the population mean. It's equal to 20. That's mu, if you remember. The population mean is always mu. And it also tells us in the last line of the sentence, it has a standard deviation equal to 4, and I've copied that here. Here's our little sigma. It's equal to 4. Now question 7.11c says, calculate the probability that we will obtain a sample mean greater than 21. Okay, so we really have all of the information that we need to finish this problem. Let me pull down the shade here a little bit and reveal some things that we discussed last week in class. Now here are some assumptions that you need to make now that we're looking at samples and not at the entire population. Two assumptions that you need to make. The very first one is this, and that is that the population mean is exactly the same as the sample mean, which in this case is going to be 20. So it's not stated in the problem, but what you need to understand when we're taking samples of many samples, and we start to distribute those and see where they fall on the normal curve, the sample mean has the exact same value as the population mean. Okay? Next is this. We are going to need to figure out what the standard deviation is of the sample. And so let me just make this correct here and put a little bar above the x here, just like this. Okay, so the standard deviation of the sample is equal to the standard deviation right here, as you see, of the population, right, this 4 that you see, divided by the square root, here's the square root symbol, of the sample size. So that's this 64. Okay, so what we're going to wind up doing is needing to get a value for that. And so if I can get in here for a quick second, maybe I can put that information in. So I'm going to click on here. This is going to look a little strange to you because this is this software that I'm using at school. Okay, so let's go ahead and put in some values here and figure out what is going on. This is equal to, let's do this. Let me get my pen. Okay, so we're looking for the standard deviation of the entire population. That's here. So that's 4, all divided by the square root of the sample size. The sample size is 64. So let's do that. Here's the square root of 64. Now it happens to be that 64 is a nice, neat number. We can find its square root quite easily. And if you remember, that's 8. Okay, so what does this equal? Sorry, my handwriting looks like a third grader. So here's a 4. And if we take the square root of 64, that's 8, right? So that's 8. And if I divide this out, I get 1/2. Right, 1/2 or 0.5, whatever you want to use. Okay, so we calculated this value. This value is going to be very important to us in just a moment. Okay, now we're ready to finish the problem. So here is what the question is really asking. The question is asking us, what is the probability, here it is, I'm pointing to it on the top right, that we will find a sample mean x bar, right, that's sample mean, greater than 21. So we just put that into our probability form, And now we're going to find out, we're going to convert this x bar value, the 21, to a z-score. Okay, ready? Here we go. I'm going to grab my pen and let's copy some more numbers down. So to find the z-score, to find the probability that x bar is greater than 21, we need to get a z-score. So what is, this is x bar. What is the sample mean? Sorry, what is the sample mean is going to be greater than 21. So we're going to take this value of 21. Okay, and from it, I'm going to subtract the population mean. The population mean is 20. Okay, do that. And I'm going to divide that all by the standard deviation, put a little bar on top, of the sample size. Standard deviation of the sample size, we just calculated up here. So that is 1/2. Okay, that's a 1/2, believe it or not. So really what this comes to is 20 divided by 21 minus 20 is 1 divided by 1/2. Let me take my time doing this. Okay, if you take out your calculator and you take 1 and divide it by 1/2, in other words, how many halves go into 1? If you have an entire pizza, for example, how many half pizzas are there in an entire pizza? There are 2. The answer is 2. Okay, and so now we've transformed this problem to read as follows. What is the probability that not x bar, we've now converted to a z-score, that z is greater than, I'm going to make the z in that format, is greater than 2? Well, that's pretty easy to do, because all we're going to do is go to the z-tables, answer this question, and we're done. So I'm going to do that in just a moment. Okay, so if you remember, here's our bell curve. And if we're looking for the probability that z is greater than 2, so here's where z is 0, right, halfway through. And so z is greater than 2 is somewhere over here. We want to find this little probability right here. Now, if you remember the z-tables, we talked about this for the last couple of weeks. It adds up the probabilities from the left-hand side all the way to the right. So if I want to find this probability, what it really is, this becomes nothing short of doing this. What is the probability of finding that z is less than, I'm going to try to do this fast, folks, z is less than 2, right? Because when we look up 2 on the z-tables, it gives us what the probability of being less than 2. So that would be all of this white region. If I want to know what the probability is of being greater, as we really do here in the red, then I'm going to have to take the number 1, 100%, minus this probability, and out will pop my answer. Now, it turns out, if you look on the back of the table, this is going to be 1 minus 0.9772. 9772. Okay, if you do this subtraction, you're going to get our final answer of 0.0228. And if you check the back of the book, it's a perfect match. In other words, what we're saying is, if we have a sample situation as we saw above, so let me just scroll up here. If we have a situation like we do up here, where we have a population average of 20 and a sample size of 64 and a standard deviation, if we take some sample, okay, a sample of 64 out of this, the likelihood, if all of this is true, the likelihood that we're going to find something greater, an average greater than 21, given this standard deviation, is this small number of 2%, right? It's 2.28%. Well, folks, this almost took 10 minutes. Sorry to take that long, but I hope this was helpful to you.